Okay, so we have a function question here, and what we have is a formula where W represents the height of a spinach plant, and the height is dependent on X, where X is the number of days after the plant starts to grow. So this model is only valid for 35 days, and if we wanted to get a feel for how the height was progressing over time, the first thing we could do is we could have a look and see that it's a cubic function. Cubic functions go up and come down and go up again, or they go down and go up and go down again. And how do we know the difference? Well, if it's a plus x cubed graph, it looks like this, and if it's a minus x cubed graph, it looks like this. Now, we're not asked to draw this function, but it would be very easy to draw. If it goes from 0 to 35, we'd probably sub 0 into this, we'd sub 5 in, 10, 15, 20, 25, 30, and 35. It probably makes sense to go up in 5s, and it would have something along the lines of this shape. I actually can see that if I sub 0 into this function, 0, 0, 0, that means at the very start the height is 0. So this graph probably only starts here at 0, and then it progresses and increases height for 35 days. And again, we're not asked to draw it, but it's important when we're revising and we're looking at functions that we're thinking about the shape of it and what's happening over time. This is a spinach plant that's going to grow over time, probably doesn't have this decrease in part of it at all. Now, the first part of this question is so simple. It just asks us to find the height of the water spinach plant after 15 days. We're just going to put 15 into the formula, and when we do that, we can see that the height of the plant, rounded off to the nearest millimeters, is 263 millimeters. So after 15 days, it's 26.3 centimeters. Just for a bit of context, it's nearly a foot tall. Okay, if we put in 16 days, we'll probably see it's still rising, and 17 days and 18 days. But again, they don't ask us for any of that. Now, one of the things that's important when we're talking about functions is what happens when we differentiate a function. Now, differentiation is a very easy operation. We'll look at it for this in a minute. But differentiation will find the rate of change of the height of the plant. Once I put this apostrophe notation in, that means we have a different function, a function that doesn't represent the height of the plant anymore. It represents the rate of change of the height of the plant. So that's what they ask us to do in the second part. So let's have a look at that. So for differentiation, let's start off with a couple of easy examples. So let's say I have a function f of x equals 3x cubed plus 5x squared plus 7x minus 10. How do we differentiate? So the apostrophe notation is for differentiation. The power comes down and multiplies by the front, that gives us 9, and then the power reduces by 1. Look at the second one. The power comes down, multiplies by the 5 to give 10, and then the power reduces by 1, and x to the power 1 is just x. Next one, 7x. Now there is a 1 here, even though we generally don't write the power of 1. That power comes down and multiplies by the 7. The power reduces by 1, goes to 0, and anything the power of 0 is 1, so that's just 7. And then constants, they disappear, so they become 0 when you differentiate them. And this would be the rate of change of this function. Well, what about the function we have? Well, the function we have, if it has an x in it, we just drop the x, so that's going to be 0.667. Sorry, let's put in w prime x. Here, the power 2 is going to come and multiply by the 1.5, so that's 3x. And then minus 3 is going to multiply by 0.025 to give me 0.075x squared. And again, this first function, this represents the height of the plant. If I want to know the height of the plant, I sub it into this. This function, even though they don't ask me to do anything with it, it represents the rate of change of the height. And an interesting exercise is, we saw a second ago that when we put 15 into this first function, we got a height of 263 millimeters. If you put 15 into the rate of change function, you'll find that it's a much smaller number. The height of the plant is changing by a smaller amount per day. Okay, now what can we do with this information? Well, generally, let's say we have a cubic function, it goes down, it goes up, and it goes down away again, or the other way around. Well, the rate of change at the max and min is 0. So at the max, the highest height of the plant, and at the min, the lowest point in the plant, we can see that the rates of change are 0. Like, if we draw tangents here, we can see there's a rate of change it's increasing. Here's a rate of change, it's increasing by a lesser amount. But at the very top, the rate of change is 0 for a split second before the rate of change is decreasing then. And then it's decreasing by a bigger amount. So if I was to find the max and min in this question, which they don't ask me to do, I would let this formula, 0.667 plus 3x minus 0.075x squared, I would let that equal 0, and I would do the minus b formula to give me two x values, so x equals and x equals, two x values, one is the min and one is the max. And to figure out the y values, the actual heights at the x values, we'd sub those back into the original formula up here. But they don't ask us to do that in this question. But in the next question, what they've done is they've given us a rate of change. There is some function that we will never see, so it's p of x, and what they've done is they've given us the rate of change of the function. We don't care what the original function was, but this is how fast the plant is changing in its height. So this is the rate of change function. Now, none of this is really important because at the end of the day, all they've asked us to do is to solve this equation. And this equation is 1.1 plus 2.73x minus 0.078x squared is greater than 24. Well, this is just called a quadratic inequality. It's a little bit like a quadratic equation, but let me show you how to finish it. Now, let me just pause for a second because I think what's important is when we have this rate of change, if I had let this equal 0 instead of 24, let it equal to 0, and instead of saying that it's greater than 24, that would help me find the max and min. I do the minus b formula and it would find the max and min for me. They don't ask me to do that. They're just asking, where is the rate of change bigger than 24? So let's do the maths on it. And again, we have to assume this is a similar model. A plant is increasing in height. It probably only starts again here and it increases in height. And they're asking us, where is the rate of change of the increase in height bigger than 24? So there are parts of the timeline where the plant is increasing by more than 24 and then all of a sudden it stops increasing by that amount and it gets a smaller increase, and then all of a sudden at the maximum it's not increasing at all. Okay, let's do the algebra on it. The algebra is quite easy. We say that this is greater than 24, then we bring the 24 over to the left hand side and make it a minus, so we minus 24 from both sides. We say 1.1 minus 24 is minus 22.9, and then we don't like starting a quadratic with a minus, so we multiply all of this by minus 1 and it changes all the signs. But if you multiply by minus with an inequality, you have to change the direction of that inequality. So let's go ahead and do that. And now this is like a quadratic equation. I mean, if you wanted to do the minus b formula on this, that's a quadratic equation. Let's go ahead and do that. So the minus b formula, I didn't bother doing it, but like a is equal to this, b is equal to this, c is this. Put it into the minus b formula and you'll see that these are our two solutions. So they're the 2 points in time after 13.94 days and after 21.06 days where the rate of change of the height of the plant is 24. Now we're asked, where is it greater than 24? So we need to draw a little sketch like this. So here is our little sketch. With a quadratic inequality, if you remember, we get our two critical values and we put them onto a graph. So 13.94 is first and 21.06 is next. Now our inequality is up here and this is a less than symbol. So I write less than here, you'll see me put it in. And then less than means underneath this curve. Okay? And so when x is between 13.94 and 21.06. So what we're saying is from day, let's just estimate it, from day 14 to day 21, the rate of change of the height of the plant is 24. And they're the answers to the question. Now that's tricky stuff. I think that's a very tricky question to get our head around, but it does just involve a bit of differentiation. The initial part and then this second part requires us to remember how to do a quadratic inequality. And quadratic inequalities people generally forget how to do. They normally solve this quadratic equation to give two answers, but they forget how to finish the sketch. Okay, tricky question.